Hello, we are Group 3 of K74 from the Introduction to Engineering and Design course with our project, Crystalline Nanocellulose Membrane and Whole House Filter. In our group, we have myself, 𝒂𝒏𝒐𝒍𝒊𝒏𝒆.
My name is 𝒂𝒏𝒐𝒂𝒍𝒍𝒊𝒏𝒆.
My name is Abraham Siagian.
My name is 𝒂𝒏𝒐𝒂𝒍𝒍𝒊𝒏𝒆.
And my name is Muhammad Ihsan Aminuddin.
We begin with the introduction to the theory, which is the backbone for our problem, that is microplastics, which are generally referred to as plastic particles less than 5 millimeters in size. They have been recognized as one of the biggest threats to the environment across the world, including oceans. On the right, we have sources of microplastics in oceans according to the IUCN. By 2025, it is estimated that the cumulative capacity of plastics in the aquatic world will be around 250 million tons.
The indicators for this problem are observation of plastic waste by fishermen and swimmers, and the discovery of plastic waste inside dead fishes, while the symptoms include discovery of plastic waste on shore, drainage system clogging, and discovery of pollutants in water tides.
Here is the problem tree which we have formulated during the early stages of our project.
Our literature studies include microplastics, membrane technology, water purifier, and nanomembranes. As for the state of the art, we examined a research conducted by 𝒂𝒏𝒐𝒂𝒍𝒍𝒊𝒏𝒆, where they produce a tailored membrane by mixing crystalline nanocellulose and cellulose acetate.
The approach to our design is based on the concept of treatment in the environmental protection hierarchy. Treatment techniques act to reduce the volume of suspended particles in water. In our case, that would be microplastics. These steps can remove as much of the unwanted substances before the effluent is released to the environment. Here's the design methodology that we followed. We relied heavily on existing data for our research and design. Getting to our design, the following are the criteria and constraints.
The performance criteria is measured by adsorption capacity. The data for these capacities is every nanomembrane's adsorption capacity for metal ions or dyes and other organic pollutants.
For maintenance, it is important that no frequent changing or replacement of the membrane is needed. A membrane that can be reused over and over again with little to no drawbacks from it being reused is preferred.
The physical aspect will be measured by the pore size, where it should be smaller but close to the microplastic size.
For the sustainability, it's based on the membrane's durability, recyclability, and the eco-friendly materials that are used to make it.
For the resources aspect, we've split them into two. For human resources, local experts in varying fields will be required for the manufacture and maintenance of the membrane technology. As for the materials, they should be easily available and inexpensive.
Moving on, now we're going to briefly explain how we evaluate our alternatives, starting off with the pore size. The cellulose acetate and crystalline nanocellulose got a score of 5 because their pores are adjustable and suitable for the filtration of microplastic in water. Silicon nanomembrane, however, got a score of 3 because the pores aren't very suitable for the filtration of microplastic and aren't adjustable and flexible.
Based on several research, the silicon has the greatest adsorption capacity, almost 1,000 milligram metal ion for every gram of silicon, while CNC has the capacity of approximately 700 milligrams of metal ion for every gram. And lastly, the cellulose acetate membrane can only adsorb about 88 milligram for every gram of its membrane.
For the sustainability, the cellulose nanocrystal, they are carbon neutral, recyclable, and non-toxic, with many useful and unexpected properties. For the cellulose acetate, it is bio-based and offers anti-fouling, antibacterial, and anti-chlorine. But the silicon nanomembrane is not as liable when compared to the cellulose nanocrystal and the cellulose acetate. That's why it has a lower score than the other two membranes.
For the materials, cellulose acetate and crystalline nanocellulose were each given a high score of 4 as they are naturally occurring, while silicon nanocellulose is relatively not as easy to produce. In terms of human resources, all three get an equal intermediate score of 3 due to the experts that would be required for their manufacture and upkeep.
For maintenance, crystalline nanocellulose gets 4 points because of its excellent anti-fouling properties. When fouling is reduced, less maintenance such as washing or replacement of membrane will be required, therefore making the material have minimal need for maintenance, and as such it has the highest score out of all three.
In light of the final scores, which were based on our evaluation and judgment in terms of the aspects, crystalline nanocellulose-based membrane outshined the other two overall with a total score of 24. Now I'm going to be talking about the process description, starting off with the CNC membrane. The features of a CNC membrane, such as high-strength hydrophilic surface chemistry, large surface area, and absorption capabilities, are already very promising for them to become high-end membrane. For the CNC membrane to extract and filter contaminated water generally follows the adsorption process. Basically, as the contaminated water passes through the CNC membrane by pressure, the contaminants from the water are adsorbed by the pores, leaving the clean water to proceed. Next. Now I'm going to be talking about the whole house water filter, which basically is a system designed to reduce harmful contaminants for water in a household. This is done by installing the system where the main water line enters. A whole house water filter is made up of three compartments where the water will first go through the 5-micron sediment pre-filter, where they will go through mechanical filtration and reverse osmosis to remove visible particles like dirt and sand. Then the water will be directed into the carbon tank where the water's fresh taste should be restored. The filter basically removes contaminants for absorption, where typically chlorine and chloramine compounds would stick into the carbon filter. And then the water would proceed into the 1-micron segment post-filter, where just like the previous pre-filter, the water would go through reverse osmosis and mechanical filtration to further remove smaller particles. Next. So the two ideas combined, we have come up with our own design concept. The idea is basically to replace both sediment filters, pre and post, with wound spiral module-based CNC membranes, varying their pore size. With CNC membranes' excellent features, there will be significant improvements for the system as a whole. For instance, the cost would be minimized, efficiency increased, and many more. The process is similar to whole house water filter, with the only difference being the process in the pre and post filters, since we now use CNC membrane. In the 5-micron CNC membrane, the water will go through adsorption to bind larger particles from infiltrating the system, and same goes in the 1-micron CNC membrane filter.
This is our 3D design of the whole house water filter that incorporates the CNC membrane made in Sketchup. This is the front view. This is the back view. And this is the top view. This is a 2D sketch of the spiral wound module that will be used in the whole house water filter.
So this is the 3D and 2D of the cellulose nanocrystal membrane design that we made in AutoCAD. Next. For the materials and tools, there are three main components for the filter. First, there is the membrane CNC or cellulose nanocrystal, and that will be placed inside the spiral wound module and is used to filter the microplastics. The spiral wound module is for membrane applications and to maximize the separation efficiency. The carbon tank is to remove organic and unorganic materials dissolved in tank water, and it removes odors. And then the others are just normal materials that you would need for a typical whole house filter. So from all of the materials and tools, our design would cost around $195 to $507.
The spread of microplastics in various bodies of water, including the water that is used at home, begets the need to design a tool that can effectively remove them. Membrane technology has been known for its uses in wastewater treatment and is a possible solution for the treatment of drinking water as well. From the alternative materials we have evaluated, The crystalline nanocellulose is able to offer more advantages as a material in creating a nanomembrane that can filter microplastics. It can then be concluded from our further research that incorporating CNC membrane into a whole house water filter is a viable option to decrease or eliminate the microplastic that pollutes the water.
The decision of using CNC as the nanomembrane in this water purification brings several benefits, such as high strength, hydrophilic surface chemistry, large specific area, low environmental impact, and promising absorption capabilities. However, due to its relatively small pores, membrane fouling cannot be avoided. Fouling may occur when suspended solids, microbes, organic materials are trapped on the membrane surface, causing decreased permeate flux. Consequently, higher pressure than normal is needed to enhance the passage of the water through the membrane. Although CNC has high mechanical strength and rigidity, the extra pressure needed to solve these foulings will cause high energy consumption and reduction in membrane filtration area. Choosing the spiral wound-shaped module will bring ease to its user, for one of its advantages is easy replacement of its module elements. The configuration also provides high packing density, leading to high membrane surface area.
Here's the simulation for the whole house water filter and the membrane technology. First, we have the 3D rendering of the whole house water filter done in Sketchup. Here's the membrane technology simulation. Thank you. That is all from our group. We hope you have a pleasant rest of your day.